Hey devs, Nate here again. This last week I gave a talk at GDG Seattle's I/O Extended event. In that talk, I was discussing what's new in Kotlin, some of the new features and announcements from 2019 and from Google I/O 2019. And so I thought I would kind of re-record this talk, maybe expand on a few areas, and just share that with all of you here on the YouTube channel. So we're going to look a little bit about some of the new features in Kotlin. We've had 2 releases of Kotlin, I believe, so far this year, 1.3.2, 1.3.3. Both of those are building on the larger 1.3 release that happened late last year, but they have included a number of nice small things, such as like inline type classes and some other smaller optimizations and tooling updates. So we'll look at some of those things. Finally, we'll look at Kotlin at Google I/O. There was definitely some big announcements there, especially in the world of Android development. And then we'll look at some upcoming learning opportunities, whether that be through courses or community-led events that you could use to get involved in the Kotlin developer community and learn more about the language. I'll include a link to these slides in the description down below. They're up on my speaker deck profile. And in there have all of the links to all the different blog posts and whatnot. I'll also try and include all those links in the description as well to save you some clicks, hopefully. So we'll start off by looking at the new and new-ish features that have been coming into Kotlin. So we'll talk a little bit about coroutines. We'll talk a little bit about the Flow project that's built on top of coroutines. We will look at the Kotlin X serialization library, and then we'll just rattle off a few various interesting tidbits that have happened in Kotlin as well. So if you're not familiar with coroutines or you haven't heard a whole lot about them, basically they are kind of the new idiomatic way in Kotlin to write asynchronous blocking code. Coroutines aren't a new idea by any means. They've been around for something like 50 years at this point, but they have started to become really popular again in, say, the last 10 or 15 years. Languages such as C#, JavaScript have very similar mechanisms within their languages. Coroutines essentially let you write very imperative-looking code that runs asynchronously and are more lightweight than sort of traditional threading mechanisms that we might be familiar with in Java. The Kotlin implementation of coroutines includes small primitives such as launch, suspending functions, and then other libraries such as architecture components can take advantage of those to build up more interesting functionality. An example of that is the new viewModel scope that was released recently for Android architecture components, which is a nice integrated way to help us launch these coroutines and then clean them up, which we'll take a look at later on in this slide deck. So if you haven't seen coroutine code before, here is a small example. We see we have our main function, and by using this run blocking function, we can kind of convert this into coroutine code. And so what we see here is this launch and then this print statement. So launch is going to run first, and then we are going to call print line. So it's going to print hello out. When we call launch, it's going to call the suspending function doWorld. Well, doWorld immediately sort of suspends itself by delaying for a second. And now instead of actually suspending this whole thread, which would make the hello print delay by a second, it actually suspends just the coroutine, which means the regular execution of that calling thread can continue. And then once that second is done, it comes back to the coroutine and finishes out. And then the whole run blocking block will only finish once all that work is done. So we can basically say we're going to launch something that after 1 second is going to print world. Then we're going to go ahead and print hello. And those are going to happen in the opposite order. We're going to see hello world printed out to the console. So this is just a small example of what a coroutine can look like, but it's fairly easy to trace. We don't have a lot of callbacks. We're not doing anything like RxJava where we're having to specify these threads and do all these nested things. It's pretty easy with some of these primitives to start writing this imperative looking asynchronous non-blocking code in Kotlin. And this is something that's supported anywhere where Kotlin is targeting, so it's definitely viable in the Kotlin multi-platform world. Now, we mentioned before the architecture components were using coroutines as well. So here's just one example of that, where the view model architecture component now has this view model scope. So imagine you want to do a network request when your view model is loading. You could call a suspending function to make that suspending network request within this view model scope.launch. That will then ensure that your network request coroutine is cleaned up properly if this view model goes out of scope. So that's just one small example of how architecture components are integrating coroutines, and we'll take a look at some more examples later on. There was a great talk about coroutines at Google I/O. I want to call that out here. It's Understand Kotlin Coroutines on Android, so it's got a pretty obvious title there. But this is a really nice look at what they're doing with coroutines within Android and Jetpack and how you could start leveraging that functionality in your project. Next up, I want to talk about this project Flow. Flow is part of the Kotlin X package. It lives at kotlinx.coroutines.flow. And essentially, it is an implementation of asynchronous cold streams. Now, if you're familiar with kind of reactive programming at all, or RxJava specifically, this might sound very familiar to you. Cold streams essentially allow us to define kind of this reactive code or generate output values, but it'll only actually be run if something is subscribed and listening to those values. So for example, we might not want to make a network request if nobody's actually going to handle that because it becomes just a wasteful operation. Now, previously we had coroutine channels, which were hot streams, and they could kind of do the same reactive pattern, but they were always going. You could never sort of defer the execution of that generating code to the point where something's subscribed to it. And this Flow project then also brings with it commands like filter, fold, or map, things that you're familiar with from, let's say, the Kotlin collection standard library or from RxJava, so that once we are sort of collecting or responding to these values, we can transform them using functional operators that we're familiar with. So like I said, this Flow project it's similar to RxJava. It's kind of the cold stream equivalent that we have in RxJava. And now with channels and Flow, we have both kind of the hot and cold streams that you might want, which is great because they're both supported for Kotlin multi-platform development. So now you can write fully reactive code using traditional patterns that you might already be familiar with if you're working in a Kotlin multi-platform code base. So here's an example of what a simple flow would look like. We've defined this property called ints, which is a flow of ints. Within that flow block, we can iterate 10 times. Within sort of each iteration of that loop, we're going to delay for 1/10 of a second. So that will essentially just suspend that coroutine for 1/10 of a second, and then we're going to emit a value. Then down below, we call collect on that ints property. Collect is a terminal operator, which will essentially collect each value emitted by the flow and then let you handle that however you want. So in this case, we will print out every value returned to us through that flow, which will take 10 values total, all delayed by 1/10 of a second. So that whole runtime will pay a full second, but it's not going to be blocked at any point because it's going to be running asynchronously in these coroutines, which will suspend and unsuspend as needed based on those delays. So this is an efficient way of getting that reactive code in a way that's going to be very familiar if you're used to something like RxJava. Now, the Kotlin X serialization library is another interesting thing that I saw at Google I/O. It's been out for a little while now. And essentially, it's a way to generate cross-platform reflectionless serialization from your Kotlin code. So if we look at this example here, we can see that we've defined a data class named data that has a couple properties. We've then added the serializable annotation to that. This then tells the compiler to generate a serializer class for that data class. Then using the Kotlin X serialization JSON class, we can call stringify or parse to either convert that model to JSON or to convert it back from JSON. So this lets us replicate behavior from, let's say, Moshi or JSON using this Kotlin X serialization module in a way that is compatible in Kotlin multi-platform projects once again. So this is a really convenient way of managing your JSON parsing. And then there's been a lot of other things come out in Kotlin language-wise. We have incremental support for capped now, which is a big deal if you're in an Android project with a lot of annotation processors and you're using Kotlin. We have unsigned integers now. We have CocoaPod support for Xcode and Kotlin multi-platform projects. The Kotlin Gradle DSL works better for multi-platform projects now. We have a lot of new tooling inspections, lint warnings. So they're really doing a lot of work between Google and JetBrains to make Kotlin development as great as possible across any of the target domains. So now let's get into announcements related to Kotlin from Google I/O. And the biggest one here is probably Kotlin First. It's not a new feature or anything, but I think it represents a bit of a change in mindset. For the last 2 years, since Android was officially announcing support for Kotlin, the Google party line has been they're going to have equal support for C++, Java, and Kotlin. Well, now we're finally seeing a little bit of a shift in that, saying they're going to focus on Kotlin first. And so while that's interesting for me as a Kotlin, someone that's interested in Kotlin, it made me question really what that meant in practice. Well, they had a slide about that. And so really it seems like they're going to be moving more and more towards building functionality and features that are going to be designed with Kotlin in mind from the get-go, or maybe only available in Kotlin, such as with Jetpack Compose, which we'll talk about in a bit. So a place where we're starting to see evidence of this is with architecture components. We're starting to see new APIs and stuff added specifically for Kotlin, and thinking very specifically about how you might use them in the larger Kotlin ecosystem. So for example, here we have a coroutine worker for Work Manager. We now have support for suspending functions in retrofit and room, which allow us now to kind of move more and more of our code into this coroutine-based paradigm. We have helpers to make coroutines play well with live data. We also have testing package to help us test our coroutines. So this is all kind of evident that they are really investing more and more into coroutines in the larger Android Jetpack ecosystem. And a huge example of this then is Jetpack Compose, which I think was probably the biggest Android-related announcement here, just because it represents possibly the largest change down the road in how we build our applications. So Jetpack Compose is a new reactive UI toolkit written entirely in Kotlin. It lets us write declarative UI very similar to what you might be familiar with from Flutter or React Native. So it's really this idea of UI as code that responds to state changes that are passed in. Now, this new UI toolkit is going to be completely different from the existing one. It's going to render views to the screen in a different way. It's going to be unbundled from the framework, meaning that can be fixed and iterated on more quickly like any of the other Jetpack libraries. And this represents a huge change because it's going to allow them to move more quickly, fix things faster. You won't have to wait for your minimum API levels to catch up to a bug fix. And just this kind of change from this very XML dominated UI world into this declarative code-based UI world. It's possibly a really big change. I'm interested to see what that looks like down the road. Now, Compose is kind of made up of two things. We have the new UI library, which are going to be the new versions of things like button, text view, animation code. And then we have the Compose compiler, which behind the scenes kind of converts that into the actual rendering code for us, as well as making sure that kind of the reactive nature of our code and state all work together. So here's a simple example of what this looks like. We can define functions that essentially return unit, and annotate them with composable. So these composable functions then can be generated into what we see on the screen. So in this case, this counter composable function will render out a text and a button to the screen. We can also add state to this by this plus memo function, which will then instantiate an instance of counter state in this example to represent the state of this composable. We can then add the model annotation to counter state to indicate to the compose compiler that the properties of that class should be observable. So we don't have to define them observable, but the composable elements will be able to react to them as if they were, which is pretty cool. And then we can kind of shim this into the existing UI layer by calling setContent and passing in our top level composable element. So if you are familiar with, let's say, Flutter, this probably looks very familiar. But if you've never worked with a declarative UI framework, it probably feels very, very foreign compared to the XML-based UI that you might be used to. So we'll see what kind of comes of this project. It's very interesting. I'm excited to see where it goes. Fair warning, though, it's very, very early days. It's in pre-alpha right now. It's in AOSP, which means you can look at it, you can grab the code, you can build it. You need a special version of Android Studio to actually be able to develop with it, but the possibility is there. However, if you don't want to go through all of that work right now, it's probably quite a while before we're going to be using this in our production Android applications, but I'm curious to see where it goes, and it kind of represents this first big shift into Kotlin first from the Google team on Android. So there were a few other kind of notable talks related to Kotlin at I/O, and I have a playlist on my YouTube channel, which I will link to down below, that kind of includes all of these, but a few of them were this Understanding Kotlin Coroutines on Android that I mentioned before. There was mobile backends with Kotlin and Google Cloud. This one was really interesting if you want to maybe use Kotlin to stand up a simple backend service. They actually stand up two different backend services with kind of Google Cloud and KTOR, all within the scope of one talk. I attended that one in person. It was pretty cool to see how easy it is to actually deploy your own backend, something that I'm personally planning on playing with sometime soon for a little small side project. There was also what's new in Android. There was Kotlin under the hood. Both of those are very interesting. The declarative UI patterns talk was really this talk about Jetpack Compose. And even if you're not that interested in Compose, it's interesting just because they get into the history of the existing UI toolkit, and you hear some of the kind of complaints, some of the lessons learned. They mention how I think it's either the view or the text class is something like 30,000 lines long, which is a lot of code for a single class. And you can go in and look at it yourself, and sure enough, it is 30,000 lines long. So you can see kind of their motivation for why they want to change to this new toolkit. And then lastly, you have this what's new in Kotlin on Android, kind of a, well, probably a more in-depth, longer version of kind of some of the stuff I've shared here. But if you just want to see more about where the team is going with Kotlin on Android, check out that talk as well. And then finally, you just want to mention a couple learning opportunities that are coming up to help you get more involved with Kotlin or the Kotlin community. So the first one being the Developing Android Apps with Kotlin by Google course. This is a new course built in conjunction with Udacity and Google. It's really meant to help you learn how to build Android apps kind of in this new Jetpack architecture component paradigm that they're recommending, and it's done all in Kotlin. So it's a great way to brush up on both of those skills, and it's completely free. So you don't need any kind of Udacity subscription to be able to access this course. And the second one is Kotlin Everywhere. Kotlin Everywhere is a new initiative sponsored by JetBrains and Google to sort of help the community put on community-led events related to developing with Kotlin across any domain. So if you want to see if there is an event in your area, or maybe you want to host an event, you can go to the Kotlin Everywhere site. There's a link in the slide. There'll be a link down below in the description. And with that, you can kind of register your event. With that, you will get kind of a PDF back, I believe, that has a lot of information about how to go about setting up an event, how to kind of market your event, how you might go about creating slide and designs. I think they will give you possibly some monetary assistance and some help finding speakers possibly too. So they're really putting a lot of work into trying to make these events great. So if you want to see if there's one close to you, check that out. They've got a cool little map that shows all the events. And if you want to host one, also check it out. And with that, that's kind of all I have for this slide deck. Like I mentioned before, there's a bunch of links here to blog posts and videos. I'll include all of these in the description down below. They're also in my speaker deck slides here if you want to check that out. And with that, I hope that this was informative, kind of maybe point you towards some different Kotlin related things to take a look at. If you want to chat more about Kotlin, feel free to reach out to me on social media, leave a comment down below, ask your question. Love to hear what other people are doing with Kotlin, and I will catch you in the next video. Thanks for watching.